About 66 million years ago, an asteroid hit the Yucatán Peninsula in Mexico. The collision triggered an extinction event that wiped out the dinosaurs and almost destroyed all life on Earth. The asteroid hit with the same energy, with 100 million atomic bombs, and left scars as wide as 150 kilometers, which is now known as Chicxulub Crater. A team of geophysicists have drilled a giant cavity under the Gulf of Mexico. They target a series of circular hills, called the crust ring, that lies at the center of it. Their discoveries illustrates that a strong impact can catapult buried material deep in the crust. Distant planet closer to its surface, Chicxulub is the only crater on Earth with the crest ring intact that we can take the sample. The next intact peak ring will be on the Moon, said Sean P. S. Gulick, a marine geophysicist from Texas University. Chicxulub is point zero of the critical extinction event. The team collected core samples that contained limestone and the rest of the rocks that break and melt. After that, they take a core with pink granite. Dr. Gulick and his colleague Joanna Morgan, a geophysicist from Imperial College London, leading the team. The team consists of more than 30 researchers, representing 12 countries, to drill Chicxulub. By drilling a rock below the surface of the ocean, they found that the top ring is made of granite, usually found much deeper in the Earth's crust. They concluded that the asteroid impact was so powerful, thus lifting the sediment off the bottom of the Earth's crust a few kilometers up to its surface. These rocks behave like a liquid for a short time, and rocks don't tend to do that, said Dr. Morgan. This thing is a very dramatic process when it forms large craters. Results of the team were published in the journal Science, with title, The Formation of Pickings in Large Impact Craters. Research results could help end the debate over how crater Chicxulub formed within minutes after the colossal collision. This research can also provide support on dynamic collapse model theory. The theory states that asteroid impacts are so powerful so that it shakes the rocks within the Earth's crust and causes lifted before collapsing to the surface to produce a crest ring. Their findings pose challenges to other models, which states that the crest ring is formed by melting the top of the crust. Core samples taken from Chicxulub Crater, suggesting that the crest ring, made of granite, it most likely came from within the Earth's crust. Other models can't be right. Remembering what we had discovered, said Dr. Gulick, it says, this theory can also explain how massive craters found on the Moon, Mercury and Venus formed. Chicxulub Crater buried under sediment for 66 million years, and if you see him now, you will see that half of it is underwater, and the other half is covered by the rainforest. The team does its work on top of the ships were turned into drilling stations, which is about 64 meters above the Gulf of Mexico. To reach the peak ring, the team needed to drill for about 18 meters of water, then through about 600 meters of rock, lime and sediment, others that have accumulated since impact. When digging into in the crust, they collect drill cores. The core of the drill was a cylindrical rock sample, 3 meters long, drawn by drill. For a while, the team continues to pull the core of the drill, which is filled with limestone. Also the rest of the broken and melted rocks, called breccia, initially inert in the form of limestone and breccia, and then all of a sudden, pink granite, said Dr. Gulick. The findings were encouraging. The granite looks like a kitchen table. Classic pink granite. They reach granite ring tops about 760 meters below sea level, but they think it might have come from the crust, which was probably over 7,620 deep before impact. This is a major discovery, because it shows that these crest rings doesn't come from anything superficial at all, said Dr. Gulick. Peak ring must have come from within, because it's made of rock crust deeply buried in the surface. The team discovered anything else during the excavation. They saw that the sample, the granite they found, was weaker and lighter than normal granite. Some were even crushed at their hands. One of the team's next steps is figure out how exactly rocks. It got to the point where they were so weak. Rocks are weak until it can behave like a liquid.